Namaste, viewers. Welcome to the Indology and Indian History YouTube channel. Today, we are going to discuss a very interesting paper. It's a paper from 2016, and the name of this paper is Ancient Human Migration After Out of Africa. The primary author here is Daniel Schreiner, and he's got another very interesting paper which we'll discuss some other day. But for today, let's focus on this ancient human migration after out of Africa, as it has some nice implications. This paper has some nice implications and interpretations with respect to Indian history. So, as you can see in the abstract here, the author studied, you know. Uh, Basically 3,528 unrelated individuals from 163 different global populations. To be very specific, this small team of researchers was investigating whether Cushitic ancestry. Now, what is Cushitic ancestry? It's the Horn of Africa. If you've seen the area around Somalia, that's the region we are talking about, which is very close to, Arabian Gulf and the Arabian Peninsula. And that would be the place where you would expect any migration coming from the side of the Indian subcontinent to land first if it was coming overland through the coastal route. So yeah, so they were investigating whether Cushitic ancestry has an East African or a Middle Eastern origin, and the results were very interesting because they found evidence for non-tree-like behavior in terms of few migration events. So, what is a tree-like behavior? Let me explain that. So, essentially, if we think of modern humans and different populations as coming from, the same ancestors, then you will have a tree-like behavior because at different points from the same tree, branches will split off, and that's how you'll have, say, Germans, Italians, Indians, Persians, so many different branches. So what they found here is that there was non-tree-like behavior in the case of Cushitic ancestry, and they found it to be a mixture of ancestries that are closely related to Arabian ancestry and, on the other hand, to Nilo-Saharan or Omotic ancestry. So this would be, in the case of the Cushitic ancestry, this will be the African source, and this is the Asian source. The Arabian ancestry is the Asian source. So then the authors also say that they found additional migration events in the histories of, number one, Indian and Arabian ancestry. So that's where the Indology channel gets interested in this paper. Second, Kalash ancestry. Again, these are people from the northern part of the Indian subcontinent. So again, this paper is very fundamentally important to us on this channel, Indology and Indian history. And number three, they found evidence also for migration events in the case of Native American and Northern European ancestries. So basically, guys, it's a very interesting paper for our subject, and therefore let's jump right into it. So, okay, we'll study a little bit of the introduction here. So the authors say, okay, that the recent origin of modern humans reflects migration from sub-Saharan Africa, with the oldest divergence event at approximately 140,000 years ago evident from the analysis of different paternal y-DNAs, so paternal haplogroups and autosomal markers. So autosomal markers, basically these are population-wide ancestry markers. So essentially, if you were a part of, say, the North Indian population 30,000 years ago, then probably that would be an autosomal marker that should show up when we study your genome. So that's a bit of background here. So now let's pay attention to the second paragraph here. Although most ancestry showed topological consistency in phylogenetic relationships, assuming a strictly bifurcating or tree-like process. So this is what I was talking about some time ago. So if we assume all of us had common ancestors, then our populations have branched off through a tree-like process. But then Cushitic ancestry showed unstable placement between East African and Middle Eastern ancestry. So that's where it becomes clear that strictly tree-like process hasn't been followed. So again, let's read this fully. Cushitic ancestry showed unstable placement between East African and Middle Eastern ancestries, and Melanesian ancestry showed an unexpectedly long branch. These findings suggested the presence of non-tree-like behavior which means that some ancestries may have formed due to a mixture process rather than a splitting process, guys. So that's very important for us. So then the authors say we investigate this possibility using three different approaches: analysis of the distance matrix using split decomposition analysis, analysis of ancestry specific allele frequencies using F3 and F4 statistics, and analysis of ancestry specific allele frequencies using a graph based model of gene flow. And they find evidence for non-tree like behavior in the form of four migration events. Okay guys, so that's very interesting. Let's go further now and look into some of their results. This is the interesting part, guys, and I'm sure all of you were waiting for this, because now this becomes really important for us on the Indology channel. So guys, this is figure one here. This is the split decomposition network of ancestry. So if you look here, this part of this tree, right here, is all African, as you can see: Nilo-Saharan, Niger, Congo, Pygmy, Khoisan, Omotic. So Cushitic is somewhere here, and Indian is here at the base of this as well. Very interesting. And from the Indian base, you see all of this splitting off. Here Kalash, European, Levantine, Caucasian, Arabian, Southern European, Berber, and even Cushitic. So basically, Indian ancestry here is almost acting like a base for all of the split off. And interestingly, the Indian ancestry, this part of this network, is also central to the other side, which is the East Asian side and the Native Americans. So these are all East Asians, as you can see: Southeast Asian, Chinese, Japanese, Siberian, Native American also. They split off from these East Asians at some point. And Melanesian. So Melanesian is somewhere here, and then right here. So these guys, so Indian is almost acting like a central fulcrum here, the Indian ancestry. On one side, it seems like Kalash and all of these European and Western Eurasian ancestry seem to be splitting off from the Indian, and on the other side, all of these East Asians as well, they seem to be interacting with Indian ancestry. Very interesting, guys, but this is just the start of this. Let's go further into the very interesting findings we find here. Okay guys, let's start reading from here about usage of the graph-based model implemented in tree mix. So the authors say that the likelihood function in tree mix is a composite likelihood. It's not a maximum likelihood and cannot be used for formal significance testing. And in particular, as we increase the number of migration events fit by the model, log likelihoods became positive, raising a concern of over-specification or model misspecification. Also, the direction of migration events are not identifiable by the model. So this is very interesting, guys. Just pay attention to this. So they are saying the direction of our migration events are not identifiable by the model. Directions are assigned by assuming gene flow. And conditional on no migration events, they found that two trees accounted for 98% of the search space. The tree with the best log likelihood was found 75% of the time and contained a subtree: Arabian, Levantine, Caucasian, Northern European, and Southern European. So the way to read this: Northern European, Southern European is most recent split. Before that, they were together with probably the people called Levantine Caucasian, and before that, even the Arabians were a part of the same family of humanity. Okay, guys, let's go further. The tree with the second best log likelihood was found 23% of the time, and this one contained. So here it's very interesting. Southern European Arabian split most recently according to this second most likely tree. And this makes sense as well, right? Because Spain, the Mediterranean region of Europe, yeah, they could probably have split more recently with Arabian. It can make sense. Before that, they were together with Levantine Caucasian, the people living in Georgia and Armenia, all of that region, and also the Near East, like Anatolia and all of those places. And prior to that, even the Northern Europeans were together with all of these people. Okay, guys, there's something interesting here. So this is a tree they found which had no migration events. So in this tree, once again, let's pay attention to where the Indian is situated. Over here, we find okay, once again, Indian and Kalash split, and then Indian even like closer to the East Asians. So you see all of these Native Americans here splitting off from the East Asian tree: Japanese, Chinese, Southeast Asian, Siberian, Melanesian, and from these Indian ancestry split off, we can think of it like this. And then from the Indian ancestry Kalash, the ancestry split off. The Kalasha is very close to something known as ancestral North Indian, guys. So let's pay attention to that. So once the Kalasha split off from the rest of the Indian, then they seem to be interacting here with the common ancestors of Europeans. This is very interesting, guys. You see Berber, North African people, Levantine, Caucasian, Northern European, Southern European, Arabian. All of them, somewhere here, they're splitting off commonly with the Kalash, who split off from the Indian tree. Okay, guys, so very interesting, but this is still no migration events, tree mix. So, not so interesting. Let's find the next one, guys. This is another, this here diagram is another one of the same tree mix analysis with no migration events, but this is the second most likely picture. So here, if you see, Indian is once again, Indian is splitting off from all the East Asian ones. But here Indian is almost a tree of that same East Asian, para-East Asian group. And then from there, the Kalasha and then the Europeans, that sort of a split. And Cushitic is right here as well. So it's close to all of these people, like closer than probably it is to, say, the rest of the Africans. Okay, very interesting. But now let's go on and start reading some of their further modeling based on one migration event. So in the one migration event, they observed the tree containing Northern European, Southern European subtree 71% of the time, and the tree containing Southern European, Arabian subtree 27% of the time. And the same migration event was inferred for both trees, and this is very interesting, guys. Look, for both of these trees, there was a migration event where there was some gene flow between Kalash ancestry after it diverged from Indian ancestry and the internal node representing the common ancestor of Arabian, Levantine Caucasian, Northern European, and Southern European ancestries. Very interesting, guys, and this is the diagram that reflects it. So you see, once the Indian and Kalash split off, the Kalash then contribute here to the common ancestors of Europeans before they split into Arabian, Levantine, Caucasian, Southern European, and Northern European ancestries. So very interesting, guys. I think that's it for this video. I think this was really interesting because here we are able to see how the Indians have, or people from the Indian subcontinent have actually made a prehistoric contribution almost before the Europeans split into their various geographic entities. So the ancestors, the Proto-European ancestors, were already affected by the Kalasha, which is actually a proxy for Proto-North Indian. So basically, the ancestors of current North Indians had a genetic impact on the ancestors of current day Arabians, Levantine Caucasians, Southern Europeans, and Northern Europeans. And what other evidence do we have to support something like this, guys? Well, we have some evidence from the field of uh, cattle genetics, guys. So let's look at another paper right here. So we are going to look at a paper called Texas Longhorn Genetics, guys, and from there we will show you something very interesting. So Texas Longhorn Genetics, so there is a very important paper here that I'm looking for, and it's a paper, a few years old, paper 2013 paper, decoding the genetic history of the Texas Longhorn. Guys, let's look at this, and let's try to go further. So yeah, McTavish, so Emily Jane McTavish, she's one of the authors. Very interesting paper, guys. We want to see actually a full copy of this somewhere. So let's go back and search for this paper, guys. I'm pretty sure it's available online. So from this paper, what we are going to look at is how the Indian cattle ancestry is actually all over Africa, guys. So that's what we will use to further consolidate what we just saw about the early interaction between the ancestors of today's North Indians and right here, guys, this is the paper and the ancestors of Europeans. So this is the paper we're going to look at. New World cattle show ancestry from multiple independent domestication events, guys. We're not really concerned so much with the entire discussion about how the Texas Longhorn came about, but we want to look at some of the diagrams they have created in this very interesting paper, guys. And one of them is this right here. So if you look at this graph, this is what we're looking at. So this is where that ancestry is located, the Cushitic ancestry. So you see the black here represents indecine cattle genome. So almost the majority of the cattle in that area of the Cushitic ancestry people is Indian cattle, guys. That's why it becomes so important to recognize that some of the modeling that these people were doing, where they said that the Kalasha had an early interaction with the Proto-Europeans, we are almost able to judge the location of this interaction based on this here graph, which shows the proportion of Indian ancestry of cattle in different parts of Africa. So right here in the Horn of Africa, in the area of the Cushitic ancestry, or the cattle genome is overwhelmingly indecine. So therefore, the early interaction which they are talking about of where all the Arabs and the European ancestors were together, we can probably think of it to have happened somewhere in this region, guys. You know, as right at the almost in this area, this entire area probably. This is a very interesting area. I think this is where that event might have happened. With that, our discussion today on this excellent paper by Daniel Schreiner on ancient human migration after out of Africa comes to an end, guys. Please hit the like button, subscribe to this channel, and also leave comments, guys. I'm really interested in hearing what you have to say about the content that we have covered today, and I will also try to respond to any interesting comments you have. And definitely I will hit like on your comments if you have something good to say, either about the video or about the content, and also any comments you have on this excellent topic of ancient human migrations that are also related to the Indian subcontinent. Thank you very much for joining today, and have a great rest of your Sunday.